Welcome to Study Loop.
So we know that the surface area for a box with edges x, y, and z is 2 times xy plus xz plus yz, and that's equal to 64. We also know that the volume is x, y, z. When we solve for z with our surface area, we get 32 minus xy over x plus y. So the volume as a function is going to be v of xy, and that's going to be xy times 32 minus xy over x plus y. So we want to maximize this function since we know the partial derivatives. The partial derivative of x is going to be negative x squared plus 2xy minus 32 y squared over x plus y squared. And the partial derivative of y is actually going to be very similar, so we can just copy it and paste it right here. The only difference is this, of course, this is going to be the partial derivative with respect to y, and then these values are going to change right here. So we'll have y squared plus 2xy minus 32, and this will become an x squared. Everything else is going to stay the same though. We know that x and y must not be 0 because the volume would be 0 in that case. So we want to find a critical point from the system. And when we set these equal to 0 up top, obviously since these aren't equal to 0, we're just focusing on this portion and this portion right here. So we have that x squared plus 2xy minus 32, or actually equals 32, which is just going to be equal to 32, which is the same as y squared plus 2xy. So when we solve, we get that x equals y. And then since x plus y equals 0 is not physically possible, we have to go with plugging in y and x somewhere else. So we get that x squared plus 2x squared equals 32. That's going to yield that x equals 4 root 2 over 3. And that is our value for y as well. So now all we have to do is find x, or z. So when we plug in our previous values of x and y, we get that this is the same thing for z as well. So it's 4 root 6 over 3. Centimeters. So when we look for our volume is going to be 4 root 6 over 3. 4 root 6 over 3. And that's going to end up giving us 128 root 6 over 9 centimeters cubed.